Hi everyone. Today we're going to study how to simplify rational expressions. Let us first define rational expression. A rational expression is an expression of the form P over Q, where P and Q are polynomials and Q is not equal to 0. We know that P is called the numerator and the Q is the denominator. We have here examples. The first is negative 25 over 56. Second example. Third example, the numerator is 4x plus 1 over the denominator x squared minus 9. Fourth example, the numerator is 4x squared plus 3x minus 1 all over the denominator 2x minus 8. Now let us define simplified rational expression. A rational expression is considered simplified if there are no common factors in its numerator and denominator. Example, the 5x over 12y is simplified because there is no common factor in the numerator and in the denominator. Another example is 7y over 9y. This rational expression is not simplified because of the variable y that is common to the numerator and in the denominator. Also, let us define equivalent fractions property. If there are three numbers a, b, and c, where b and c are not equal to 0, then if we have a rational expression a over b, we can multiply the a by c and multiply the b with that same value c. Also, if we have a fraction capital P over capital Q, and this P can be factored out into A times C, and the Q can be factored out into B times C. Then we can cancel that C, and the rational expression becomes A over B. In some books, you will read this as cancellation property of fraction. There is a note: you can remove a factor from a product. You cannot remove a term from a sum. Later on the video, we will see the meaning of this note. How to simplify rational expressions. We have two steps here. In step 1, factor the numerator and denominator completely. Step 2, simplify by cancelling out common factors. Let's have example 1. Simplify 36v cubed w squared all over the denominator 27v w cubed. In step 1, we will factor the numerator and denominator completely. In the numerator, the 36 becomes 4 times 9. The v cubed, we wrote here the v 3 times. For the w square, we wrote the W here 2 times. Let's go to the denominator. The 27 is now factored out into 3 by 9. And the V variable is copied. And the W cube is now written here 3 times. In step 2, we will simplify by cancelling out common factors. Look at the 9. It is common to the numerator and denominator, so we cancel the 9. The V is common to the numerator and denominator, so we cancel it out. There are 2 W's in the numerator, 3 W's in the denominator. We cancel the 2 W's in the numerator and the 2 W's in the denominator respectively. So after cancelling all the common factors, we will collect the remaining terms. So in the numerator, we copied number 4. And for the variable v, there are 2 v's here. So I put here v square. In the denominator now, I copy number 3. And also the w. So this is now our answer. Let us have example 2. Simplify the rational expression. The numerator is x squared plus 6x plus 8. All over the denominator, x squared plus 9x plus 20. I wrote the steps on this side. Let us now do the step 1. Factor the numerator and denominator completely. The numerator becomes x plus 2 times x plus 4. The denominator is factored out into x plus 4 times x plus 5. And then in step 2, we will cancel the common factors. There is x plus 4 and also x plus 4 in the numerator and in the denominator respectively, so we can cancel it out. What remains in the numerator is the x plus 2, while in the denominator is this x plus 5. So we can remove the grouping symbol. One note is written here. You can remove a factor from a product. You cannot remove a term from a sum. It means in here the x and the x, we cannot cancel that because the x here is part of the sum of the numerator. Also, the same way with the x in the denominator, it is part of the sum with a positive 5. So this is our final answer. Let us have example 3. Simplify the rational expression a squared minus 4 in the numerator all over a squared plus 6a minus 16 in the denominator. Let us now factor out the numerator and denominator completely. The a squared minus 4 becomes a plus 2 times a minus 2. In the denominator, the factors are a plus 8 times a minus 2. Now, we will cancel the common factor, and that is the a minus 2. So in cancelling, we will now go to the next line. We will copy the remaining factors. In the numerator, it is now the a plus 2, and in the denominator, it is the a plus 8. So again, we cannot remove or cancel the a and the a because the a here is part of the sum of the numerator. And also the a in the denominator is part of the sum with this plus 8. So our final answer, a plus 2 over a plus 8. Hi everyone. Today we're going to study multiplication of rational expressions. Let us see this principle about multiplication of rational expressions. If P, Q, R, and S are polynomials where Q is not equal to 0 and S is not equal to 0, then if we have the fraction P over Q times R over S, this is equal to the product of PR in the numerator over the product of QS in the denominator. How do we multiply rational expressions? We are going to have these 3 steps. Step 1, factor each numerator and denominator completely. Step 2, multiply the numerators and denominators. Step 3, simplify by cancelling out common factors. Let us see example 1. Let us multiply the rational expressions. The first one is the 3x all over the trinomial x squared minus 6x minus 16 times another, the numerator is x squared minus 4 all over the denominator 6x squared. In step 1, we are going to factor each numerator and denominator completely. The 3x, we can show that this is 3 times x. The trinomial x squared minus 6x minus 16 is now factored out into x plus 2 times x minus 8. And then the second rational expression, in the numerator, the x squared minus 4 is now factored into x plus 2 times x minus 2. In the denominator, the 6x squared is now written as 2 times 3 times x times x. In step 2, we will multiply the numerators and denominators. So it is like we're going to combine all numerators as 1 and also all denominators as 1. So it will be like this. The 3 times x times the x plus 2 times x minus 2 in the numerator. In the denominator is the x plus 2 times x minus 8 times 2 times 3 times x times x. And then step 3, we're going to simplify by cancelling out common factors. The 3 times x here, we can cancel out with this 3 times x here. The x plus 2, there is a counterpart of x plus 2 in the denominator. So we can cancel those terms. You see here, the 3 times x is cancelled with this, and the x plus 2 is also cancelled in both the numerator and in the denominator. And then we will just copy the remaining factors. In the numerator, the x minus 2 will come down here. In the denominator, the number 2 is here, followed by the x and the binomial x minus 8. So this is our final answer. Let us have example 2. Let us multiply the rational expressions. Our first rational expression, in the numerator, n square minus 5n all over the n square minus 25 times the second rational expression. The numerator is n square plus 10n plus 25 all over 5n square. So I wrote all the 3 steps here at one time. So I'm going to do the step 1 to factor each numerator and denominator completely. The n square minus 5n is now factored out into n times the binomial n minus 5. The denominator n square minus 25 is now the product of n plus 5 and the n minus 5. The numerator n square plus 10n plus 25 is now factored out into n plus 5 times n plus 5. While this 5n square, it's now factored out completely into 5 times n times n. Actually, we can skip the step 2. We can go directly to step 3 by cancelling out common factors. This n here, we can cancel with one n here. And the n minus 5, there is also n minus 5 in the denominator, while the n plus 5 here can be cancelled with the n plus 5 in the denominator here. So you see, the respective factors are now cancelled. And then we will just collect the remaining factors. In the numerator, only the n plus 5 remains. In the denominator, we write the 5, also this n. So this n plus 5 over 5n is our final answer. Let us have example 3. Let us multiply these rational expressions. Our first rational expression, the numerator is 3a squared minus 8a minus 3 all over a squared minus 25. The second rational expression, in the numerator, it is a squared plus 10a plus 25 all over 3a squared minus 14a minus 5. So I wrote the steps on this side, and I will now go to step 1 to factor each numerator and denominator completely. In the numerator, in our first rational expression, the 3a squared minus 8a minus 3, the factors are 3a plus 1 and the binomial a minus 3. If you are not familiar with the factors, you can review our video about factoring of trinomial of the form ax squared plus bx plus c. So in the denominator, the a squared minus 25, the factors are a plus 5 and a minus 5. And then times the second rational expression, the a squared minus 10a plus 25 is now factored into a minus 5 times a minus 5. The denominator 3a squared minus 14a minus 5. The factors are 3a plus 1 and a minus 5. Also, we can skip the step 2. We can go directly to step 3, and that is to simplify by cancelling out common factors. Look at this 3a plus 1. We can cancel this with the 3a plus 1 in the denominator of the second rational expression. The a minus 5 can be cancelled with the a minus 5 here. There is another a minus 5 where we can cancel this with the a minus 5 down here. So you see now the respective factors are now cancelled out. And then we will just collect the remaining factors. So in here is the a minus 3. We copy down here. We can remove the grouping symbol. And in the denominator, the remaining factor is the a plus 5 only. So we will just copy that. Also, we can remove the grouping symbol. The next question is, can we cancel this a and a in the denominator? The answer is here. There is a note that we cannot remove a term from a sum. So the a in the numerator is part of the sum a plus a negative 3. In the same way, the a in the denominator is part of the sum of a plus 5. So this a minus 3 over a plus 5 is our final answer. Hi everyone. Today we're going to study division of rational expressions. Let us have the formal definition of division of rational expressions. If P, Q, R, and S are polynomials, where Q not equal to 0, R not equal to 0, and S not equal to 0, then the rational expression P over Q divided by another rational expression R over S is equal to P over Q times S over R. In words, to divide rational expressions, multiply the first fraction by the reciprocal of the second. And the final answer is, we multiply the numerator by numerator becomes PS. We multiply denominator by denominator and the answer is QR. How to divide rational expressions? And we're going to follow these 4 steps. Step 1, we write the division as the product of the first rational expression and the reciprocal of the second. Step 2, factor the numerators and denominators completely. Step 3, multiply the numerators and denominators together. Step 4, simplify by cancelling out common factors. Let's have example 1. Divide the rational expressions. Our first rational expression in the numerator is x cubed minus y cubed. All over, the denominator is 2x squared plus 2xy plus 2y squared. Divided by another rational expression, the numerator is x squared minus y squared. All over, the denominator 4. Step 1 says we are going to rewrite our problem into multiplication of the first rational expression and the reciprocal of the second. So it means the first rational expression we will just copy down here, and then we will change the division into multiplication symbol, and then we take the reciprocal of the second rational expression. Look at the denominator 4. It becomes the numerator down here, while the numerator here becomes the denominator here. And step 2, we will factor the numerators and denominators completely. Our numerator in the first rational expression, x cubed minus y cubed, this is the difference of two cubes, so the factors are x minus y times the trinomial x squared plus xy plus y squared. If you are not familiar with the factors of these two cubes, please check again our video about factoring of two cubes. In the denominator, there is a greatest common factor of 2, so we move the common factor out. So what remains in the trinomial is now x squared plus xy plus y squared. For the second rational expression, the number 4, we can write it to be 2 times 2 over the denominator x squared minus y squared. This is difference of two perfect squares, and the factors are now x plus y and x minus y. For step 3 and step 4, we can combine them, and we can now proceed with the cancellation of common factors. Look at the x minus y here. We can cancel this with the x minus y down here. The trinomial x squared plus xy plus y squared, there is corresponding factor down here also, so we can now cancel both. The number 2 here can now cancel with the number 2 in the numerator of the second rational expression. We can now collect the remaining factors after cancelling respective common factors. In the numerator, it's only number 2 that remains, so we will copy that down here. In the denominator, the binomial x plus y remains, so we will just copy it here. So our final answer is 2 over the x plus y. Let's have example 2. Divide the rational expressions v minus 5 over 11 minus v divided by v squared minus 25 over v minus 11. So I wrote all the steps here. So I will apply step 1 to write again this problem, but I will change the division into multiplication and take the reciprocal of the second rational expression. So it's now here v minus 5 over 11 minus v times the v minus 11 over the v squared minus 25. And step 2, I will factor out the numerators and denominators completely. Our first rational expression, the numerator and denominator is already simplified, so we will just copy it down here. While the second rational expression, let's begin with our denominator. The v squared minus 25 is now factored out into v plus 5 times v minus 5. In the numerator, the v minus 11, we can write this as the negative of 11 minus v. We put it this way so that later we can cancel this with the 11 minus v in the denominator here. So we will now go to step 3 and the step 4. We will combine them. we will now cancel common factors. The v minus 5 can be cancelled with the v minus 5 here. The 11 minus b, we will now cancel with the 11 minus b. And when we collect the remaining terms, take note, there is a negative sign there, so we will put here minus 1 over the remaining factor in the denominator is the v plus 5. So our final answer is the negative 1 over v plus 5. Let us have example 3. We have a rational expression x squared plus 3x minus 10 all over 4x divided by a polynomial 2x squared plus 20x plus 50. The steps are here to guide me. I will begin with step 1. I will rewrite this again as the product of the first rational expression and the reciprocal of the second. So our problem now becomes the first rational expression and then times. Number 1 is now the numerator all over this polynomial. So the 2x squared plus 20x plus 50 is now in the denominator. I will go to step 2 to factor the numerators and denominators completely. The numerator x squared plus 3x minus 10 becomes the product of x plus 5 times x minus 2. And then I will just copy the 4x down here. In the second rational expression, the number 1 is there in the numerator all over. The trinomial here, there is a greatest common factor of 2. We put it outside. What remains in the first term will be x squared. In the second term will be 10x. In the third term is 25. But I can see here that this x squared plus 10x plus 25 can still be factored out. So I'll do another line to copy everything and to put the factors of this trinomial into x plus 5 times x plus 5. And then I will now go to step 3 and step 4 to cancel common factors. The x plus 5, I will now cancel this with another x plus 5 here. And no other common factors that we can cancel. Let us now collect the remaining factors. In the numerator, the x minus 2 times 1, we will have the x minus 2. In the denominator, we multiply 4 times 2 becomes 8. And the x will just copy here. Also, there is the binomial x plus 5. We'll just put it down here. So our final answer is this x minus 2 over 8x times the binomial x plus 5. I hope you learned something from this video. See you again next time.
Thank you.